Today is February the 21st, and this video will show how the soft start works when connected to a firing board on the ISO VLCL2 when connected to a firing board. In the event of the board manually soft stop or soft started, and in the event of a current trip. Under normal conditions, what we have here is the ISO VLCL2 connected through this cable through a firing board, FCOG 6100 board, and on this setup we are using 240 volts AC. We have a bridge rectifier inside this cabinet. Or AC input, it's 244 volts AC, or DC output, it's 319 volts DC. From our shunt or feedback is 50 millivolts, and we can see those light, the load blowing. So what I'm going to do is I have this meter, and I'm going to be poking around this signal. So I have, if I go to the board at J4 position 4 or J5 position 5, if I come here, I have approximately 9.5 volts, and it has 9.5 volts because on J3 position 12 from the firing board I have 12 volts. So those 12 volts going through a pull up resistor, it's coming down to be 9.5. Now if I go to test point 6, the output of the soft start and current trip, I will have roughly the same video. It's just a little low. Now there's two ways to drop this voltage. The first one is when we manually take this signal and we pull it to ground, and Tony is going to show how that's going to happen. At this point it's now 0.4. We'll notice that the firing board, it's inhibited. We can see the red LED, and that's because we manually inhibited the board. Nothing will happen. The board will never enable if we don't release that contact to common. Notice, and when I'm going to ask Tony to release that, let's take a look at that red LED. The board is enabled. Everything is back again. And that right there, it's a slowly soft starting, and it's charging that capacitor C12. Again, it's going to get to about 9.5. It's still going there. It's slowly getting to the end of the ramp. Well, let's just do it one more time, Tony. Hold on. Let's just verify. It'll still be a couple of seconds. Let's go ahead. Let's inhibit. So again, this is manually. And let's go ahead and wait until, go ahead. It's slowly ramping up. Test point 6 is ramping up. And it's not because of that capacitor, it's because of this capacitor here, C12. And we can see that the voltages is slowly getting there. And the output voltages is slowly getting there. That's one way to drop the output of the soft start current. Now, the other one is in the event, as we pointed out, of a current trip. So for this part of the test, we have a 50 millivolts. I'm going to ask Tony to reduce the current trip pot on the threshold, and I'm going to take a look at test point 2. You notice that I have an oscilloscope prop there, so I'm going to first look at it with the meter on test point 2. And under normal conditions, there's no current trip. The board is happy. We have 11 volts, test point 2, and as Tony drops it, keep in mind that this has a manual reset, automatic reset. We'll see that the LED is tripping. We hardly see any change on that. Bring it back and keep it tripped, Tony. Just keep it tripped right there. We hardly see any change on the oscilloscope. It's only going from 11 to 10 volts, and that's why here, although the LED is tripping, I have to go back and take a look at the green channel, and we can see that it actually drops. This is 5 volts per division, so that's 12. We can see that it momentarily drops all the way down. right there. And that's not enough to drop that voltage. And more importantly, when we go to test point 6 again, see that it's just moving around because it's coming up and down, up and down. Again, in order for this to happen, there's only a current trip condition, and the board should not be soft inhibited manually. Now let's go ahead and bring it back, Tony, and let's do the same thing with the voltage trip. So again, your Tony's back to now because of the trip, it's still, every time you have a trip, it's soft start, so it's still soft ramping up or charging up that capacitor. Just wait a little until we have the end of the soft start. Now we don't have any trips. This is solid, although I'm looking at current trip. Let's go ahead and do the voltage trip now, Tony. So there it is. We're still again. We have the LED, and there we're doing the same test point 6. So this suggests that if there is a problem with the soft start, the unit not picking up, it's because it's if it's not manually soft inhibited, you have a current or a voltage trip momentarily keeping the board from fully enabling. Now I'm not going to go to test point 2. I'm going to go to test point 6. Keep it on voltage trip, Tony. And there it is. Well, we can see how it's slowly coming up, but it's tripping. You have that situation, so it brings it down again, and it's starting to go up. So this is how the soft start works, either when manually soft inhibit or when tripped by a current or overcurrent or over voltage protection that in turn discharges that capacitor. It's not until that situation clears that the capacitor is allowed to come back up and charge up again. This is the end of this video. All right.